Talking about transformation of functions, you are going to find that there are some things that we know about from this that will be the same, some things that will be new. For example, we have talked about vertical shifts, horizontal shifts, vertical stretches or compressions, and we have reflected graphs across the x-axis. What is going to be a little bit new, we haven't really explored this yet, is first of all the terminology. When you reflect across the x-axis, it is called a vertical reflection, which might seem strange because you think the x-axis is the horizontal axis, which it is, but it is actually a vertical reflection. I'll show you that. We are going to talk about horizontal stretch or compression, which we did not really explore much last year, and we are going to look at reflection across the y-axis, which is a horizontal reflection, and how that is related to the transformation of functions. So first I'm starting with one that you're very familiar with. So I'm going to plot our parent graph for f of x equals x squared. So we know our points that we used. Won't say much about that. And then we're going to graph this. Okay. So remember how this changed. We vertically stretched by 2. So it was vertically stretched. Remember, this was 3 to the right. So this is our horizontal transformation, and our vertical transformation, this was up 1. Now, the way that we did that is we started with our locator point, and we went to the right 3 and up 1. And then from there, we went over 1, and instead of up 1, we went up 2, because we doubled that. We went back to our locator point, over 2, and instead of up 4 like the parent graph, we went up 8. Hope I counted that right. And then we graphed that. And that's still fine. But there are going to be some types of problems where we're going to have a little different, I want to show you a different strategy. Before I do that though, let me relate these two graphs in a different way that you're going to see in this section, and that is the relationship between g of x and f of x. We're taking 2 times f of x minus 3 plus 1. So this is telling me it's vertically stretched because I have a 2 out front. It's horizontally shifted 3 to the right and vertically shifted up 1. Notice that in this notation that there's no reference to the fact that my function f of x is x squared. So this would work for any function that has been vertically stretched, horizontally shifted 3 to the right, and vertically shifted up 1. It could be an absolute value function or some other kind of function. So I do want to show you a different way to do the same problem. There is an order that you want to do these transformations in, and we have 3 things here. So I'm going to start with the vertical stretch. And then we're going to do the horizontal and the vertical shift. And it really doesn't matter whether you do the horizontal shift or the vertical shift, which order of those. But there are going to be some functions and some of the ways where we're given the functions where we actually don't know what the function is, so we can't graph the locator point and do what we were doing in Algebra 2. So we do have to apply the vertical stretch component first before we can do the horizontal. So I want to just relate it back to a graph that, again, we're familiar with. I'm not going to plot the parent function. Yeah, I will. Let me just get that on. I'm only going to plot the points though, so that we'll use those. I'm not going to actually draw in the graph. Okay, so I'm going to vertically stretch by 2. So I'm going to start with my 0. And notice the height f of x is at 0. So if I multiply by 2, that doesn't change anything. Let me change my color though. So that won't change, it's still 0. Now I'm going to go to the right 3 and up 1, and there's 1 point. I'm going to make little x's just so they'll stand out. Then I'm going to go to this other point here, f of 1. Well, notice I have a vertical component, or this right here is at a height of 1. So I'm going to double that, which puts me here at a height of 2. So I'm doing the vertical stretch first. So now I'm at a height of 2, and I'm going to go 3 to the right and up 1. Move to the next point. I'm at a height of 4. I'm going to double that, vertically stretch it by 2, so I'm going to be at an 8, and I'm going to go over 3 and up 1. And I'm here. Then I'm going to go to this point over here, yeah. So I'm at a height of 1. I'm going to double that. So I'm going to go here, sorry. And I'm going to go to the right 3 and up 1. One more. I'm at a height of 4, double that, to the right 3 and up 1. Notice my points, and I'm not actually going to draw this in because I'm not very good at drawing this in on this board here anyway, but you can see that's exactly the same thing that I got here. So we get the exact same value. So this is going to help us when we have the functions presented to us in a different format. So when we are just given maybe a table of values or something, you want to do the stretching part first. So here for this example, I'm going to stick with what you know first. So our basic absolute value graph. So I'll just plot a few points here. Make my line straight. Okay, so all right, so let's take a look now. We know that this, we know about this shifting, so it's going to go 1 to the left. We're going to go down 2. And the negative sign, this is going to reflect across the x-axis. And this 1/2, it's going to be compressed, vertically compressed. Okay, so let's find these old way we did before. Our new locator point, we went 1 to the left and down 2. So we plotted this point here. And then we were reflecting over the x-axis. It opened down. Actually, I think that's what we talked about. Instead of opening up, it opens down. So I know it's going to go down instead. I'm going to go, it acts like a slope of a 1/2. So if I go, so we're going to go, okay, down 1 over 2, sticking with our old way that we did before. And we could continue that pattern. So this is how we did it before. Should have got my straight line tool out there. And we had a graph that looked like this. Now I want to talk about the other way. So first of all, when I relate these two functions, I'm going to have g of x equals negative 1/2 f of x plus 1 minus 2. So those are my transformations. So what I'm going to do first is I'm going to be compressing by a 1/2. So I'm going to apply that part first. Then I'm going to reflect. Then I'm going to go 1 to the left and down 2. And that part wouldn't matter as far as the order on those last 2 steps. So let's plot the points here just so I have those as my reference points. That's enough. Okay, so here goes. If I take 0, that's a height of 0. If I multiply that by a 1/2, it is still 0. Reflecting it across the x-axis, it doesn't go anywhere. So then I'm going to go to the left 1 and down 2. And here's my new point. Okay, so that's where that point is moving to. So now I'm going to go to this point right here. I'm at a height of 1. 1/2 of that would be a 1/2. So here I'm right here. Now reflect that across the x-axis. So now I'm down here at -1/2, and then I'm going to move to the left 1 and down 2. And that puts me right here. Okay, next point. I'm at a height of 2. When x equals 2, I'm at a height of 2. I'm going to do half of that, so I'm at a height of 1, reflect it across the x-axis, so I'm at -1, and then go to the left 1 and down 2. Now I'm here. Go over to this point. When x equals -1, I'm at a height of 1. Take half of that. I'm at a half. Reflect it across the x-axis. I'm at -1/2. Didn't mean to draw that point there. Oh, I can get rid of that. I'm at -1/2. Then I go to the left 1 and down 2. I'm here. Next, I'm at a height of 2. Half of that is 1. Reflect it. I'm at -1. And I go to the left 1 and down 2. And if I draw this in, and you'll see the graph, the points, like I'm at the point 1, -3 is on my new graph, and look back here to compare it, and you still have 1, -3 on there, so just wanted to show you it was a little different on how we did that, but this is going to help you on some of the other problems we do if you think about it that way. But our old way still works for those kinds of functions. If you're just asked to graph a transform function, you can find the locator point and do it the way that we did before. Okay, different, let's take a look here. For our parent function, f of x equals the square root of x, we have 0, 0. The square root of 1 is 1. The square root of 4 is 2. So here was my graph. Okay, now I'm going to do this one. If you remember, we kind of had some trouble last year in deciding where our points, we found our locator point, the 1, 3, but some of you had some trouble knowing how to plot this one. It wasn't quite as obvious. So let's try our new method and see if this helps a little better. So when we do this, I can see that this is vertically stretched by 2. So we're going to be doing that part first, the vertically stretched. And I'm going to put by 2. So we're multiplying, we're doubling the height. Then we're going to go to the right 1 and up 3. Okay, so let's try that. So if I'm at a height of 0, well then doubling that, it's still 0. So I'm going to go to the right 1 and up 3. Here I'm at a height of 1. I'm going to double that. So now I'm at a height of 2. I'm going to move to the right 1 and up 3. Here I'm at a height of 2. I'm going to double that and be at a height of 4. Now I'm going to move to the right 1 and up 3. So my new graph, or my transformed function, becomes this. And I think you'll find that a little easier. So how do these two graphs relate? I can say g of x equals 2 times f of x minus 1 plus 3. That would be the relationship between those two functions. Again, notice this is in terms of f of x now. It doesn't actually have the fact that it was the square root of x. Since I already did it that new way, don't need to worry about that. I want to show you what happens in this particular graph. So here is just our square root function. So I'll put that back on here. Okay, now this one is just reflecting across the x-axis. So reflect across x-axis. And if you think about what this is saying, the relationship here is g of x is negative f of x. Okay, because we have square root of x is f of x. So g of x is negative f of x. So that's what that first one is that we're looking at. So what does that mean? That means I'm just making that, taking my y value and making it the opposite. So what that graph is going to look like, the 0 is still going to be at 0 because when you reflect that, it's still there. Instead of being at a height of +1, I'm going to now reflect that and be at -1. Instead of being a height of 2, I'm going to reflect that and then be at a height of -2. So when I graph this, I get something that looks like that, except it would have been smoother, but it's kind of hard to draw in here. So there's my graph. Now the reason why this is called a vertical reflection, again, is we are reflecting it in a vertical direction when it goes across the x-axis. So now let's think about what this means. Now, first of all, my domain, if you look at my domain for f of x, remember that we know that x has to be greater than or equal to 0. So what does that imply here? Well, if negative x has to be greater than or equal to 0, because that's what's underneath the radical, then if you multiply both sides by -1, you get x is less than, because we flip the inequality, or equal to 0, it's still going to be a 0. So we're going to see that the values of x, this just means x is negative. So what's going to happen if x is 0, it's still going to be 0. If x is -1, then the opposite of a -1 is +1. The square root of that would be 1. If x were -4, then you would have the opposite of -4 is +4, and the square root would be 2. Well, notice my graph is just reflected across the y-axis on this one. It's called this one is called a horizontal reflection because we're reflecting it in a horizontal direction. So that's what you do with the reflection. Now notice this is a little different because that minus x is inside here. Now if I were going to relate those two functions, I would say, for this one, would be g of x equals f of -x. And that's how I would relate those two functions. Okay, so now here we go. This is the big one. Now this has got something different in it. This has got, notice this 3 right here, and we're going to have to do something different with this one. This is going to be a horizontal, actually it's going to be a compression, and it's kind of opposite of what you might think. But one of the things we're going to do, the other things are all similar, but one of the things you're going to do first, and I'm just going to tell you this is how we're going to do this, is we want this in terms, we're going to factor a 3 out of this little portion in here, and we want to write it in this format because it will be easier to work with. Okay, so notice all I did, if I multiply this back in, it's 3 times x, and 3 times a third is 1. So I'm just working right here with this little portion here and factoring the 3 out and writing it in this format. Now, the reason why I do that, because if I do it that way, then I can think of this as, this is going to actually be horizontally compressed. This is going to be vertically stretched. This is going to be shifted 1/3 to the left, and this is going to be down 5. Okay, we're going to do our new way of doing this. So I'm going to take my old points, I'm going to plot them here. And this is where we're starting. So this is step 1. We're going to think about those values. We're going to horizontally compress it, which means that it's going to, we're dividing by that value instead of multiplying. So, but I'm moving in this direction horizontally. The 0, we'll do this one. If I take 0 and I want, if I divide that by 3, I still get 0. So I'm doing that first horizontally. Then I'm doing this one second. The vertically part, if I multiply that by 2, I'm still at 0. So far, I'm still at 0. Now I'm going to go 1/3 to the left. So I'm going to be at -1/3, and then I'm going to go down 5. Let me change colors here. So 1/3 to the left, 1, 2, 3, 4, 5. Here's my new point. Okay, that's going to end up being my vertex. Next one. I go to my next point here. I am at a horizontal value of 1. I'm going to divide by 3, which is going to put me at 1/3. Okay, I'm at a height of 1, double the height. So I need to be at a height of 2. So now I'm right here. I'm going to move 1/3, and notice I'm only at 1/3 right here. I'm going to move 1/3 to the left, which will put me on the y-axis, and then down 5. 1, 2, 3, 4, 5. If you need to see that again, hit rewind when I'm done. Okay, so now I'm going to go to this next point. Notice I'm doing horizontal first. I am at a horizontal value of 2. My x value is 2. Divide that by 3. So 2 divided by 3 is 2/3. So I need to be at 2/3. So I'm going to scoot back over here till I'm at about 2/3. Now notice I'm at a vertical value of 4. I need to double that because I need to be at a vertical value of 8. So I'm going to move up. 1, 2, 3, up 4 because I was already at 4. So now I'm at a height of 8. Now I have to go 1/3 to the left. So I'm going to be at a value of 1/3 and go down 5. 1, 2, 3, 4, 5. And there's my point. Okay, back over to here. I'm at my x value is -1. I need to divide that by 3. I get -1/3, so it would be about right here. I am vertically stretched by 2. I'm at a height of 1. I need to double that and be at a height of 2. Now I am. Now I'm going to go 1/3 to the left, which puts me at -2/3, and down 5. 1, 2, 3, 4, 5. Okay, one more point here. I am at an x value of -2. I divide that by 3, which gives me -2/3. So -2/3 is about here. I need to, now I'm at a height of 4, and I need to vertically stretch it by 2, so I need to be at a height of 8. So now I'm here. I need to go 1/3 to the left, which puts me at -1, and then I need to go down 5. 1, 2, 3, 4, 5. And I'm here. And now if I graph this, which I'm going to be just bad at graphing this, so I'm going to do this. I'm going to write it this way. The point -2, 4 went to the point -1, 3. The point -1, 1 went to the point -2/3, -3. The point 0, 0 went to the point -1/3, -5. The point 1, 1 went to the point, where did we go next? 0, -3. And the point 2, 4 went to the point 1/3, 3. Now, I'm not going to do this here because we're running low on time, but on your graphing calculator, plug this into Y1, plug this into Y2, and look at a table of values. If you looked at those values, especially with the Y2 function, if you go ahead and do that and plug in these X values into your table and let it spit out the Y values for you, you'll see that those are the values and that this did work. So if you were going to relate these two functions, we would have g of x equals 2, and then how we're going to handle this one is f of 3x plus 1 minus 5. and that's what that would look like. But notice what we did first. We did factor that 3 out, and that was kind of a trick. It's kind of messy if you don't do that, because then you have to do like, it's just messy if you don't do that first. So you really do want to do that step first, because it will make your life a little easier.